the new point internal energy we have to see. Now what is definition of internal energy? Internal energy in thermodynamics denoted by the symbol capital U is there. Now you know that internal energy means what? Every substance or every animals there is a one type of storage amount of energy are present that in a system called as a internal energy directly. You take the every substance directly. There is a one type of storage amount of energy present is there. This energy called as a internal energy. And this internal energy denoted by the symbol the capital U is there. Also the internal energy of system is nothing but it is the sum of kinetic energy and potential energy of particles of each system is directly. So the internal energy is equal to internal energy symbol written in the U. U is equal to Ke plus Pe there. Now Ke means kinetic energy plus P means potential energy. But delta U is equal to U2 minus U1 is directly. Now delta U how calculated? The U2 you take the initial internal energy U1 suppose and U2 that is a U2 is a final internal energy. So delta U means actually change in internal energy. Change in internal energy how calculated? Final internal energy minus initial internal energy. In this way delta U can be calculated by the using the formula directly. Now U is a state function, also it is a extensive property directly. Now you know that is a U is a state function. Why it is a called as a state function? Because the internal energy depends only the initial state as well as final state is there. So it is a state function. It not depends upon the paths is there actually. So called as a state function is there according to definition of thermodynamics is there. Also extensive property there actually. You know the property which depends upon the magnitude of matter present in the system called as a extensive property there actually. Because this property only depends the initial value of the internal energy as well as final internal energy value there actually. So the it is a called as a extensive property. There is a one that is a answer is a important internal what is definition of internal energy, how calculated internal energy. Internal energy is a state function, explain it, and extensive property. Why it is a called as a extensive property? That's this internal energy that point is a computed directly. बघा यामध्ये इंटरनल एनर्जी म्हणजे काय आपण पाहिलं म्हणजे प्रत्येक जे सबस्टन्स आहे कुठलाही सबस्टन्स असू द्या कुठलाही ॲनिमल असू द्या त्यामध्ये स्टोरेज अमाऊंट ऑफ एनर्जी असते त्या एनर्जीला काय म्हणतो आपण इंटरनल एनर्जी असं म्हणतो. इंटरनल एनर्जी असेल तर आपण थर्मोडायनॅमिक्समध्ये त्यासाठी कॅपिटल यू हे सिम्बॉल वापरायचं आहे. म्हणून इंटरनल एनर्जी हे सुद्धा होऊ शकतं. इंटरनल एनर्जी म्हणजे काय की कायनेटिक एनर्जी प्लस पोटॅशियम एनर्जी याची बेरीज टोटल काय होते इंटरनल एनर्जी होऊ शकते. आता कॅल्क्युलेशन इंटरनल एनर्जी कसे काढतात तर त्या डेल्टा यू डिफरन्स कसा काढला जातो तुम्हाला पाठीमागं मी सांगितलेलं आहे. फायनल मायनस इनिशियल फायनल इंटरनल एनर्जी U2 आणि मायनस इनिशियल इंटरनल एनर्जी U1. By using this formula we calculate the internal energy of any substance there actually. Now then we have to the new point first of thermodynamics. What is the first of thermodynamics there? Because thermodynamics it is a branch of chemistry there which deals with the physical properties there actually. Called as a thermodynamics is there actually. Now the it is to study the heats is there actually. Now first law, what is the statements there? The first of thermodynamics is also called as a law of conservation of mass is there actually. And so the law of conservation of mass, the statement is different there. Now these statements we have to see one by one there. First statement, the total energy of system and surrounding remains constant when a system changes from an initial state to final state is there. Statement number 1, total energy of system and surrounding remains a constant actually. Now what do you mean actually system? System means that is a someone part of that someone part of universe is called as a system is there, and surrounding the part outside the system is called as a surrounding there actually. So in the total energy of system and surrounding remains a constant there actually when the system changes from one state to other states there actually. This is a one statement is a very important there actually. Now second statement, the energy of universe remains constant there actually. Now you know the energy of total universe, that is the universe means actually all the space in the atmosphere is there actually. So the particular energy are present there. This energy of universe is a remains constant there. This is the second statement of first of thermodynamics there. Now third statement, the total internal energy of an isolated system is a constant. The total internal energy of isolated system is a constant there actually. You know the actually isolated system. That is there is a three types of system. One is a open system, second is a closed system, third is a isolated system. In the when the isolated system is present, isolated system what is definition? A system which can neither exchange a matter nor energy with the surrounding, then called as a isolated system is there actually. So the total internal energy of isolated system remains always a constant value there. And this is the third statement there. Fourth one, energy neither created nor destroyed, but one form of energy converts into another forms of energy there actually. You know the actually energy is neither created nor be destroyed, but one energy converts into other forms of energy. In thermodynamics, we have to points is very important actually. Energies are interconvertible. That means actually one energy converts into other types of energy. So the fourth statement is a very important actually. Such a way that is a statements of first of thermodynamics is there. These statements are very simple in thermodynamics is there actually. Now then the next point, formulation of first law of thermodynamics. Formulation means what is the correct formula of first law of thermodynamics, that we have to see the one by one there. So according to statements, you know that actually in thermodynamics there is a four statements are there actually. And so according to all the statements there, consider one the formula, correct formula present in a thermodynamics there actually. These are called as a formulation. Consider Q amount of heat supplied to the system. Suppose a system is there, Q amount of heat supplied to the system is there, and W be the work done on the system by surrounding. The internal energy delta U of the system increases. Then now according to this equation, this information, we can write the equation increase in internal energy of the system is equal to quantity of heat supplied to the system plus amount of work done. So increase in internal energy support delta U. Amount of heat is equal to Q and amount of work is equal to W. The equation becomes delta is equal to Q plus W. This is the equation 1 is that. Now what is mean actually delta U? Increase in internal energy. What is actually the symbol Q? Amount of heat supplied to the system, and the W, amount of work done. So the equation 1 is the formulation of first law of thermodynamics. Formulation means accurate formula, accurate equation is called as the first law of thermodynamics. In short, the equation 1 is a correct equation of first law of thermodynamics. Now suppose there is a infinitely small changes, then equation 1 becomes du is equal to dq plus dw. Du means small change done in an increase in internal energy. Small change in a, that is a heat is there. Small, that is a heat supplied there, and therefore there is a small work done. How equation is written? Du is equal to dq plus dw. Equation number 2 is there. So this is a formula or correct equation of first law of thermodynamics. यामध्ये बघा, या इक्वेशन हे फर्स्ट लॉ ऑफ थर्मोडायनॅमिक्सचं हे इक्वेशन आहे. यामध्ये काय आहे, समजा एखादी सिस्टीम आहे, त्याला आपण त्या सिस्टीमला क्यू अमाऊंट ऑफ हीट आपण सप्लाय केली, तर सिस्टीमला सप्लाय केल्यानंतर हीट काय होतं, इन्क्रीज इन इंटरनल एनर्जी होते, त्याचप्रमाणे वर्क डन. बरोबर आहे. हे इक्वेशननं आपण त्यामध्ये लिहिलं, काय लिहिलं, इन्क्रीज इन इंटरनल एनर्जी ऑफ सिस्टम इज इक्वल टू हाऊ मच क्वांटिटी ऑफ हीट सप्लाय टू द सिस्टम प्लस अमाऊंट ऑफ वर्क डन. काय येईल इक्वेशन, डेल्टा इज इक्वल टू क्यू प्लस डब्ल्यू. जर आपण हे इक्वेशन आहे करेक्ट इक्वेशन ऑफ फर्स्ट ऑफ थर्मोडायनॅमिक्स आहे. यामध्ये आपण स्मॉल चेंजेस केले, स्मॉल, इट इज अ निग्लेबल चेंज कॅन बी मेड. Then which equation comes with that? du is equal to dq, differential equation. du is equal to dq plus dw. Equation number 2 is there. Now this equation 1 and 2 is used in a various process direction. You know the in thermodynamics there is a 4 processes are present there. One is the isothermal process, second is the adiabatic process, third is the isobaric process, number 4th is the isobaric process directly. Now first we have to see the isothermal process directly. Here the isothermal process, a process in which when the temperature remains constant, then called as a isothermal process. And in the isothermal process there is a internal energy is a constant directly. That means actually delta u is a 0 there. Put this 0 value in this equation. What equation comes there? W is equal to minus q there. That means when the work done in the process, then amount of heat is evolved there. Amount of heat is released to the surrounding. So that is in thermodynamics this can be done directly. Now second is the adiabatic process. Adiabatic process, you know the actually q is equal to 0 there. Amount of heat is equal to 0 because there is a insulating materials are used in adiabatic process there. Q is equal to 0. Then equation, put this value in the equation 1. Ultimately you get delta u is equal to w. That means actually work done is equal to change in internal energy. This can be done in the adiabatic process there. Now number C, isoric process. Now isoric process, when the volume remains constant, then called as a isoric process. Then delta V is equal to 0 is there actually. You know the actually. Then putting the values in the equation 1 is there. Actually you get delta is equal to Q. Means amount of heat that is supplied at a constant volume is equal to change in internal energy in the isoric process direction. The next isobaric process. Isobaric process means you know the actually when a process in which the pressure remains constant directly. That means actually pressure is equal to 0. delta P is equal to 0. The equation, put the value in this equation. W is equal to minus P delta V into delta V. So the equation 1 comes there. Qp is equal to delta U plus external atmospheric pressure into delta V. So this equation comes in a isobaric procedure actually.